All right, get ready, because we're about to take a deep dive into TypeScript. If you're here, you're probably at least a little curious about this, like, JavaScript enhancer that's been making waves. All about adding types to your JavaScript, which, believe me, can be a total game changer, especially for those massive, complex applications.
Yeah, it's really interesting how TypeScript brings order to JavaScript, a language that can be, well, a little too flexible sometimes.
Right, like, JavaScript is awesome, don't get me wrong,
Hmm.
but it can get a little chaotic out there. TypeScript is like bring in some rules, like a referee. So, okay, first things first, how do we even get TypeScript into our toolbox? I see we can install it globally or locally for a specific project.
You got it. If you want TypeScript available system-wide, you install it globally using npm, the package manager for JavaScript. It's as simple as running npm install-g TypeScript in your terminal.
Okay, so that sets up our TypeScript Sentinel command. But what if we just want to use it for, like, one specific project?
In that case, you'd use npm install TypeScript savedev. That installs it as a development dependency for that project, keeping it neatly tucked away in your project folder.
All right, and I'm seeing this tsconfig.json file mentioned. What's the deal with that? Some kind of secret TypeScript code.
More like a configuration file, lets you fine-tune how TypeScript behaves in your project. Think of it as a rule book, tells TypeScript how you want your code compiled. You can specify things like the JavaScript version you want to target, how strict you want the type checking to be, and a whole bunch of other options. And to easily generate this file in your project directory, you can use npx tsc init.
So it's like laying down the law in our TypeScript town.
Gotcha.
Gotcha. Now, let's talk about the essence of TypeScript, the types. It wouldn't be TypeScript without them, right?
Absolutely. Types are what give TypeScript its power. They let us describe the shape of our data. This helps us catch errors early on and makes the code much more readable and maintainable. We'll start with what we call primitive types. They're the basic building blocks of any data structure.
Okay, so like those colorful blocks kids play with, but for code.
Exactly. We have number for, well, numbers, string for text, and Boolean for true or false values. Think of it like labeling your containers. This one's for numbers, this one's for text, that kind of thing.
So like giving our code guidelines, making it super clear what each piece of data should be. And I'm looking at how we declare variables using these types. For example, let mark.number9 creates a variable named mark that can only store a number.
Precisely. By adding that dot number after the variable name, you're telling TypeScript, hey, this variable is meant for numbers and only numbers.
And what happens if we try to sneak in something that's not a number? Does TypeScript, like, freak out?
Not freak out exactly, but it'll definitely let you know something's wrong. TypeScript will throw what we call a compile time error. It's like having a built-in code reviewer, but like super strict about data types.
Okay, that's pretty cool. It's like a safety net to keep our code from going off the rails. So we have these primitive types for the simple data. What about when we need something more complex, like when we're dealing with collections of data?
That's where we use what are called reference types. They allow us to represent more sophisticated structures like arrays and objects.
Ah, yes, those two data organizers. Can you give me an example of how these reference types work in TypeScript?
Let's say you want to store a list of car brands. In TypeScript, you would declare an array of strings like this. Let cars, string, cars equals Audi, Cadillac, Honda. This creates an array called cars that can only hold strings.
Okay, like a special container just for strings, no mixing allowed. What about objects? How do we define their structure?
For objects, you define the types of each property. So imagine we want to represent a student with a name and a GPA. You could define it like this. TypeScript.
Name.string.gpa number, GPA, GPH name, John GPA, 8 GPA.
This makes sure that our student object will always have a name property, which has to be a string,
Yeah.
and a GPA property, which has to be a number.
So TypeScript is enforcing the structure of our student object, making sure we don't mess up the types.
Exactly. Now imagine you have a whole classroom of students all represented as an array of objects. You might start to notice some repetition in how you define the structure for each student.
Yeah, writing out that whole object structure again and again would get old fast. There has to be a better way.
There is. That's where type aliases come in handy.
Aliases. I'm intrigued.
Type aliases let us create reusable blueprints for our data types. Instead of repeating that whole object structure every time, we can define a student type like this. TypeScript, type student.string.gpa.number.jpa, and then we can use this alias to declare variables.
So,
TypeScript.
stu That's much cleaner, like giving a nickname to that complex object structure.
Exactly. It's like a shortcut, saves us a ton of typing, and makes the code easier to read. But what if a variable could hold different types of data? Let's say a password that could be a string, a number, or even a Boolean.
Yeah, that sounds confusing. How does TypeScript handle that kind of flexibility?
That's where union types come in. We use the pipe symbol to allow multiple types for a single variable.
So for a password example, it would be let password, string number, Boolean, password equals 999.
Exactly. And you can even use them with arrays as well. For example, let data.string could hold either a single string or a whole array of strings.
Wow, that's pretty flexible.
Yeah,
But doesn't all this make our code, I don't know, less predictable?
I can see why you'd think that. But don't worry, TypeScript has a secret weapon. Type inference.
Type inference, like it can read our minds.
Kind of. Even if you don't explicitly write out the type for every variable, TypeScript is smart enough to figure it out based on what you're doing.
So if I write let city New York, TypeScript automatically knows that city is a string.
You got it. It's like TypeScript is saying, I see what you're doing there. You're putting a string in that variable, so I'll just assume it's a string from now on.
That's amazing. It's like TypeScript is doing all the tedious work for us.
Yeah.
So we can focus on the bigger picture.
And it's a good habit to let TypeScript do its thing whenever possible. It keeps your code clean and avoids repetition.
Okay, I'm starting to feel like I'm getting this whole type system. Now let's move on to another core concept in programming. Functions. How do types work with functions in TypeScript?
Just like variables, functions can have these type annotations, both for their parameters and for what they return. This makes sure we're passing in the right kind of data and getting back what we expect.
So we can specify the types for the inputs and outputs of our functions. Can you give me an example?
Absolutely. Let's make a simple function to add two numbers. It would look something like this. TypeScript.
Number B, number, return a plus B.
We're telling TypeScript that this function takes two parameters, A and B, both of which must be numbers. The dot number after the parentheses means the function should return a number as well.
Okay, so we're defining the parameter types inside the parentheses and the return type after. What if a function doesn't return anything?
Then we use the void type. It's like saying, this function does something, but it doesn't give you anything back, like a function that logs something to the console.
That makes sense. Is there a way to say a function can take any type of argument?
Yes, there's the any type, but it's kind of like the wild card of TypeScript. It lets you bypass type checking, but you should use it sparingly.
It sounds like any kind defeats the whole purpose of TypeScript. When would you ever want to use that?
While it's best to be specific with your types, there are times when you might have to work with code that isn't type safe, or you're dealing with data where you don't know the structure ahead of time. But keep in mind that using any comes with a trade-off.
Right, it gives you flexibility, but you lose that type safety net.
Exactly. It's like walking a tightrope without a safety net. You have to be really careful.
Okay, I'll be careful with that one. Now, let's switch gears to a core concept in object-oriented programming. Classes, they're all about bundling data and behavior, right?
Yeah, think of them like blueprints for creating objects. Objects are bundles of data and methods that work on that data.
So how do we define these blueprints, these classes in TypeScript?
Defining classes in TypeScript is very similar to other object-oriented languages. Let's say we're making a blueprint for a car. It might look something like this. TypeScript.class, car.constructor, public model.string, public color.string, public seats, number, public features, string, public features, add feature, feature.string, add feature, feature, add feature, add feature, add feature, const car1.hook, the car, BMW 5 Series, red, 4, sunroof, backup camera, navigation system, add feature.car1.add feature, Bluetooth. This defines a car class with properties like model, color, and seats number. It also has a method called add feature to, add features to the car.
And we can create instances of this class, like car1 here, to represent specific cars with their own unique details.
Right. We can create as many instances of the car class as we need, each with its own model, color, number of seats, and features. It's a powerful way to represent and manage groups of objects that share common characteristics. And speaking of representing data, something closely related to classes are interfaces. They're super important for defining the structure and contracts of our code.
Okay, interfaces. I've heard of them in other programming languages. Do they work similarly in TypeScript?
Yep. Interfaces in TypeScript are how we define the shape of an object. They specify what properties it must have and what types those properties should be. It's a feature that you don't have in plain JavaScript. It adds a lot of structure and type safety, which is really valuable, especially as your projects grow.
So it's like a set of rules that an object has to follow to be a certain type.
That's a great way to put it. It's like saying, if you want to be considered a product in our system, you must have a name, a price, and a description.
Okay, so interfaces bring some order to the world of JavaScript objects. Can you give me an example of how to define an interface in TypeScript?
Sure. Let's say you're building an app that deals with different kinds of animals. You could define an interface called animal. It would outline the common characteristics that all animals should have. Something like this. TypeScript.interface animal breed.string.age.number say hello. This interface says that any object implementing animal must have a breed property that's a string, an age property that's a number, and a say hello method that doesn't return any value.
So like a contract that an object has to sign to be considered an animal.
You got it. Interfaces help us set clear expectations for how our objects should be structured and what methods they should have.
Okay, I get that. But how do we actually use this interface? Do we, like, attach it to objects?
We use interfaces with classes to make sure the classes follow the structure outlined in the interface. For example, TypeScript.class. While animals implements animal.string.age.number, age.age, age, say hello, age.console.log, praxo age. Here, the while animals class implements the animal interface, meaning it has to have all the properties and methods specified in the interface.
So the wild animals class is like signing a contract, promising to fulfill the requirements. If it breaks the contract, TypeScript will let us know.
Exactly. If we tried to create a wild animals object and didn't define a breed, an age, or the say hello method, TypeScript would throw a compile time error, making sure everything stays consistent.
Wow, this is really helpful, especially when you have multiple developers working on a big project. It's like having a built-in style guide for the code.
That's a great analogy. Interfaces help create a shared understanding of how different parts of the code should work together. This makes it much easier to collaborate and keep things consistent. They're a powerful tool for building robust and scalable applications.
Welcome back. I'm still processing all this TypeScript stuff. It's like we've unlocked a secret level of JavaScript.
It definitely changes the game. And what we've looked at so far are just the basics. It gets really interesting when you see how these concepts all work together in the real world.
Okay, now you've got me curious. Let's talk about interfaces again. I get the basic idea.
Yeah.
But can you give me an example? Like, how would we use interfaces in a real project?
Imagine you're building an online store, right? You'd have clothes, gadgets, books, all kinds of products. Each one is unique, but they all share some common characteristics.
Yeah, like a name, a price, a description, maybe some images.
Exactly. And that's where interfaces come in. We could define an interface called product that acts as a blueprint for all our products. It would outline those essential properties. Name as a string, price as a number, description as a string, and image URL as a string.
So it's like setting the standard for what makes a product in our online store.
Precisely. And then we can create more specific interfaces that extend this product interface. For instance, a clothing interface could have additional properties like size and color, while a book interface might include author and ISBN.
Ah, so it's like a family tree of interfaces, with product as the parent.
It's interesting how this approach mirrors real-world relationships. Just like a t-shirt is both a piece of clothing and a product, inheriting characteristics from both categories. Interfaces let us capture this hierarchy in our code.
I love that analogy. It makes it so much clearer. So we're not just defining data structures, we're also creating a vocabulary, a way to describe how things relate to each other. It's like designing a well-organized city.
Exactly. And that organization is key, especially as projects get bigger and more complex. It's like having a map to help you navigate through the code.
You mentioned before that interfaces are mainly for compile time checking, so they don't actually exist in the final JavaScript code.
That's right. Think of them like scaffolding. They provide support while you're building, but once the building is done, the scaffolding is removed, leaving you with clean, efficient JavaScript code.
That makes sense, like those temporary supports they use when building arches. They're essential during construction, but not needed once the arch can stand on its own. So interfaces are kind of like the unsung heroes of our code.
I like that. They might not get all the glory, but they're super important.
And you also mentioned that interfaces can be extended, so we can build upon existing ones to make even more specialized types.
Exactly. It's all about code reuse and avoiding repetition. Let's say you had a base interface called vehicle with properties like make, model, and year. You could create a more specific interface called car which would extend vehicle, inheriting all its properties and adding its own, like number of doors or engine type.
So we're basically saying a car is a type of vehicle, but with extra details, like inheriting traits from your parents but adding your own unique personality.
I like how you're connecting these concepts to real-world examples. That's exactly what interface extension is about, building upon what already exists to create more specialized and nuanced representations of our data.
This is all starting to click.
Yeah.
Now let's zoom out a bit. Why is TypeScript becoming so popular, especially for these large projects? What are the main advantages it offers over plain JavaScript?
That's a great question. One of the biggest reasons is the added type safety. By catching type errors during compilation, TypeScript acts like a safety net. It prevents those nasty runtime errors that could crash your app.
So it's like having someone constantly double-checking your work, but for data types.
That's a great way to put it. It highlights how TypeScript helps you identify and fix potential problems early on.
And catching errors early is crucial, especially in a large project where a small bug can snowball into a huge mess.
Absolutely. It's like fixing a leak before it floods your entire house. And besides type safety, TypeScript also brings more structure and clarity to your code, making it easier to read and maintain.
Right. With the types clearly defined, it's much easier to understand what a piece of code does, how it interacts with other parts of the application, and what kind of data it's supposed to handle.
Exactly. It's like having well-written instructions for your code. This is especially helpful when you have a whole team working on the same project. It keeps everyone on the same page and reduces errors.
It's like everyone speaking the same language so they can understand each other.
And let's not forget about refactoring and debugging. Making changes in a big JavaScript project can be scary, but with TypeScript, it feels much safer. You can refactor with confidence, knowing that TypeScript will catch any type-related mistakes.
It's like having a guide dog leading you through a dark forest. You know you're in good hands, even if you trip.
That's a great image. It shows how TypeScript helps you make changes without being afraid of breaking things.
Okay, I'm convinced. TypeScript sounds like a superpower for JavaScript developers. But let's be real, how hard is it to learn for someone who's used to playing JavaScript?
The good news is it's not that hard, especially if you have a good grasp of the basics of JavaScript. Learning TypeScript is more about getting used to some new tools and embracing type safety.
So it's like adding to your JavaScript knowledge, not starting over.
Exactly. And there are so many resources available to help you learn documentation, tutorials, online courses. There's a whole community of TypeScript enthusiasts out there.
That's encouraging. It makes learning TypeScript seem less daunting. So it sounds like learning TypeScript is a good investment. It'll make you a better and more confident JavaScript developer.
Absolutely. It's definitely worth the effort.
Earlier, you mentioned that TypeScript is particularly popular with frameworks like Angular. Why is that? What makes them such a good match?
With Angular being a framework for building complex web apps, uses TypeScript as its primary language. It's built right into the core of Angular, providing pipe checking for everything.
So if you're learning Angular, you're basically learning TypeScript at the same time.
While you can technically use Angular with regular JavaScript, you'd be missing out on a lot of what makes TypeScript great. It's like trying to build a house without power tools. Sure, you could do it, but it would take much longer and be a lot harder.
Right, you'd be giving up all that precision and efficiency. So TypeScript and Angular really work well together.
Absolutely. And other frameworks like React and Vue.js are also starting to use TypeScript more and more.
It's like TypeScript is becoming the standard for modern JavaScript development.
That's a great way to put it. It's becoming common practice, which lets developers switch between projects and technologies more easily.
This has been a really deep dive into TypeScript. I feel like I have a much better understanding of it now.
I'm glad to hear that. We've covered a lot of ground, from basic types and functions to more advanced topics like interfaces and classes. We've seen how TypeScript brings structure, safety, and clarity to the world of JavaScript.
And this is just the beginning. There's still so much more to learn about this powerful language.
Definitely. There's always something new to discover with TypeScript.
I'm already feeling inspired to try out TypeScript in my own projects.
That's great. And remember, there's a whole community out there to support you.
That's good to know. It makes learning TypeScript seem much more fun. I think we've given our listeners a great foundation to build upon. Now they have the knowledge and hopefully the motivation to start their own TypeScript journey.
I agree. We've sparked their curiosity and given them a starting point.
Now, before we wrap things up, let's leave our listeners with something to think about as they learn more about TypeScript. We've talked about all the technical benefits, but I think there's a bigger lesson here. Something about the importance of structure and clarity, not just in code, but in our thinking as well.
That's a great point. It reminds us that the same principles we use for good code, like clarity, consistency, and predictability, also apply to communication and collaboration in all parts of life.
Exactly. So as you learn TypeScript, remember, you're not just learning a language, you're also developing a way of thinking that will help you in all areas of life.
I like that.
So with that, we'll wrap up this deep dive into TypeScript. A big thank you to our expert for guiding us,
My pleasure.
and to our listeners. Keep learning, keep experimenting, and keep that TypeScript spirit alive.
Happy coding.
Until next time on the deep dive. It's been quite a journey exploring the world of TypeScript, and honestly, I'm feeling pretty excited about it.
Yeah, I get that. There's something contagious about discovering a new tool that can completely change how you approach coding.
Absolutely. As we wrap up our deep dive, if our listeners were to take away just a few key things about TypeScript, what would you want those to be?
Well, I think the most important takeaway is that TypeScript is an enhancement to JavaScript, not a replacement. It builds upon what JavaScript already does well, adding more structure, safety, and predictability, which is really crucial as projects get larger and more complex.
Right, it's like adding a booster to an already powerful engine.
That's a great way to put it.
We've talked about a lot of benefits: type safety, readability, better collaboration, easier refactoring. These all sound great in theory, but I'm curious, how do these benefits actually play out in a real-world development team?
Let's picture a team working on a big e-commerce site, right? Without TypeScript, they might run into a situation where someone accidentally introduces a bug by passing the wrong type of data to a function. And this bug might go unnoticed until it causes a problem in production, leading to unhappy customers and lost sales.
Yikes, that sounds like a disaster. How would TypeScript help prevent that?
Well, with TypeScript, that bug would probably be caught during compilation. The compiler would point out the error, giving the developer a chance to fix it before it ever affects users.
Ah, so it's like having an extra pair of eyes constantly checking the code.
That's right. And this isn't just about preventing bugs, it also has a big impact on how developers work together. With clearly defined types, there's less confusion and guesswork. Developers can work on different parts of the application more confidently, knowing that TypeScript will make sure everything fits together properly.
It's like having a shared blueprint that everyone can refer to. This must save a ton of time and headaches.
Absolutely. Think about all the time saved on debugging or on those long conversations trying to figure out why something isn't working. TypeScript makes communication easier so developers can collaborate better.
That's a huge advantage. And it seems like the benefits of better collaboration go beyond just the developers themselves.
Definitely. When developers can focus on building new features and solving problems, instead of getting bogged down by bugs and miscommunication, the whole project runs more smoothly. This means faster development, better quality software, and happier customers in the end.
It's like a ripple effect of positive outcomes, all because of TypeScript.
Yeah.
It's fascinating how something that seems like a technical detail can have such a big impact on the whole software development process.
It really shows how important good design principles are, and how the right tools can make a difference for the entire organization.
Well said. As we finish up this episode, I want to leave our listeners with one final thought. Something to consider as they continue learning about TypeScript. We spent a lot of time talking about the technical side of things, but I think there's a deeper message here. Something about the value of structure and clarity, not just in our code, but in our thinking as well.
I really like that. It reminds us that the same principles that make for good code, clarity, consistency, predictability, those are also important for communication and collaboration in all parts of life.
That's right. So as you learn TypeScript, remember that you're not just learning a new programming language. You're also developing a way of thinking that will help you in all areas.
That's a great way to put it.
Okay, so that concludes our deep dive into TypeScript. A huge thank you to our expert for guiding us
It was my pleasure.
and to all our listeners.
Yeah.
Keep exploring, keep experimenting, and keep that TypeScript spirit going.
Happy coding.
We'll see you next time on The Deep Dive.